So can anybody help us to define induction? That what did you learn last time? What is the fundamental principle on what kind of things we can apply induction? Huh? Go ahead.
Basically, induction is a process of.
Very good. Induction is a process of proving something. So is it the case that there might be certain situations where it will be really difficult to apply induction? And what will be those kind of situations?
For example, we cannot define a base.
Okay. When the base case is not obvious, then it may not be like very obvious to move on for induction. Any other comment that where induction will become bit hard to apply to prove a given statement? Okay, yep.
I think we can only use this technique when our cases have the cardinality which is equal to the cardinality of natural numbers.
Excellent, right? So, so if I retranslate that cardinality stuff, so essentially we'll be able to apply it when we are talking about something which is related to integers, which is countable, right? And by countable we mean from our cardinality concepts that if something is mappable to the set of natural numbers, then that thing is countable, and if it is countable, then we can apply induction, and we'll see some reasons and examples in a while. So what we saw last time was that we have been given this this sequence of different dominoes. They have been vertically placed, and then there are two things which are given to us. One is that through some mechanism, through some physical intervention, the first domino falls. So if the first one falls, it hits the next one. When it hits the next one, the next one falls, and then that next one will hit the next to next, and this chain will keep on going. So because they are like placed next to each other. So if the first one is falling, that is causing a ripple effect. So this will be the somewhat like intermediate kind of situation when some ith, a tile or domino falls, then it hits I plus 1, and as a result you get all of them except the last one hitting each other, and all of them will be falling. So intuitively, this without looking at the mathematical side, intuitively this makes sense. If they are fallable, so we have placed them vertically. If the first one is hit, if it falls, it hits the next one, and so on. So that ripple effect continues, and eventually we get all of them done. So if we try to translate this thing in terms of our propositions, so what we call is that when you say the first one falls, that means P naught is true. P naught is a proposition which is true, and that's our task to prove that thing. And some of you actually named that thing as the base case. So base case is true in that case. If the base case is true, then P naught is true. If P naught true, the first one will fall. So it's given, right? So it's given. At the same time, we'll have to demonstrate that thing that because if that thing is not true, then rest of the story cannot be built upon that. Okay, and please keep this thing in mind, because in some of the proofs or incorrect examples which we'll see in a while, we might be having certain situations where this thing is not true, but rest of the things are being proven, right? So we might, if we just somehow overlook this thing P naught, we might be proving something correct which is actually incorrect, right? So if the first thing, if the base case is not true, then we will not be able to move on. So the proving this thing is the probably easiest step in this whole proof stuff. P naught is given. Usually we need to know the base case, we need to know the start point. By start point we mean the first domino, right? So we will be notating it as P naught. So then, if you are here, so what we have seen so far is that the first one is falling, it will be hitting next one, next will be hitting next to next one, and so on. So if some ith tile falls, it hits the next one. If it hits the next one, next must fall. And that's what we are notating over here as an implication. So if k tile is falling, that will hit the next one, and k plus 1 will fall, right? And so this is what is the crux of that whole induction stuff, that pk implies pk plus 1. So if your statement, if your proposition is true for k, then it has to be true for k plus 1 if the bigger statement is true. And range of k is that it is starting from 0, and we are claiming that this has to be true for all k. And the reason we are putting all k over here is the same exactly this effect, right? So this domino effect is coming into play over here mathematically, that for all k starting from the 0, the first one falls, it hits the next one, second one, then second one falls, it hits the next one, and this chain keeps on going, right? So one thing, the cardinality wala stuff that we talked about, so that is very obvious. So each of those, the number of tiles are mappable to set of natural numbers. They are discrete, they are countable, so nothing is continuous in between, right? So in order to move from k to k plus 1, we need to have a discrete step. If that step is not possible, then things won't be really possible for us to demonstrate or to prove. So if these two things are true, if we have established somehow that P naught is true, and if we also establish that this implication that Pk implies Pk plus 1 is also true, then if we take an AND between these two, that means that all of the dominoes will fall, right? And summary of all of this whole crux is written over here, that P naught is true, and for all k this implication is true. So if both of these things are true, there is an n in between. If both of them are true, that implies that our given statement is true for all n. Okay, so this principle is known as the fundamental and probably the simplest version of mathematical induction. And please stop me if there is any question in between. So let's try to apply these principles using an example. So we've been given this proposition. Probably you saw it last time as well. So the left hand side says that I starting from 0, there's a loop starting from 0 going up till n, and this is summing all first n integers, and the right hand side is, what do you call it in terms of summations and sequences? What was this number called? Sum of first positive n integers, and what was that particular number? Tn, right? This is called triangular number, right? So Tn, so n into n plus 1 over 2. So our first ICP is that you have to quickly, in next 30 seconds, you have to rewrite this whole statement, because over here it does not tell us much about what kind of n is there. So just try to make it little more explicit, and then we'll move forward. And the hint is already there, right? So we have to just make it explicit in terms of all positive integers. So this is how it will be looking like, right? So essentially you are only expected to write this kind of quantification around n that we are talking about. So because this statement only talks about one n, but we are claiming that this has to be any n. There's no limit on n, and has to be a member of set of natural numbers. This is what we have to prove, or alternatively we can write it like this if the whole statement is Pn. Okay, so as like this is an outline for almost all kinds of proofs which we'll be doing using induction. So the first step over here is that we will be establishing the base step. We'll be establishing the base case. Sometimes we'll call it as basis step, where we establish that P naught is, and P naught is the starting point of your loop, right? So if you look over here, so I is 0, so we will be establishing it for the first possible substitution of I. And then inductive step is this implication. We will assume that Pk is given. If Pk is true, then we apply that Pk plus 1 is true. And if we are done with both of those things, then our intuition, which we saw using that dominoes effect, that says that if these two things are true, if P naught is true, which is the basis step, and if you somehow prove this implication that this is true, then we are done that this statement is true for all integers, right? So base step is that P naught, so we substitute 0 over here, I is 0, the loop runs up till 0 because n is 0. So essentially loop is running only one time. So what will be the left hand side? 0, and right hand side 0, and this should be quite clearly, concretely visible to the reader that you have established base step, right? And then the next step is that we assume, so we had an implication, right? Implication had this form. Pk implies that Pk plus 1 is true. So the given thing is this if wala part. So this is given, right? This is what we call inductive hypothesis. So we assume that Pk is true for some k which is greater than or equal to 0. So if Pk is true, then this statement is true, that if the loop is running from I0 to k, then k, this is equal to k into k plus 1 over 2. We're just plugging in value of k in place of n, and that will be the version whom we'll be referring as inductive hypothesis, right? And in terms of implication, this is what Pk is. This is given, okay, and because this is an implications, we don't need to establish pk in itself. This is given. If this thing is true, the only task which is left is that we have to establish pk plus 1 is true. So because we are plugging in k plus 1 over here in place of n, then on both sides n will be replaced with k plus 1. So left hand side the loop will be running from 0 to k plus 1, and on the right hand side all places where n was previously inserted in the original statement, that will get substituted with k plus 1, right. So this is the kind of shape we want to prove. This is our task. This is something which we have to establish based on these two things, right. So we can use both of the previous steps which have been given. pk is given, we can use that, and inductive inductive basis is given, so we can also use that. So this is the like same piece of content which was here on the lower side of the slide. So these 3 lines have been just replicated over here so that we can refer to them. So what we do is that we run the loop, we pick the left hand side of what we have to establish. I is running from 0 to k plus 1, so we do 2 things. We separate out the last term. When we separate out the last term, we are left with the loop is running from 0 to k, and then we add the last term explicitly into that summation outside the loop, right. Now the reason we are doing it is that now if you look at this blue part, this is actually exactly same as the left hand side of our inductive hypothesis. This is pk, left hand side of pk. So what we do is that we plug in our inductive hypothesis in place of this blue summation, and this becomes k into k plus 1 over 2 and then k plus 1. Now if you solve it mathematically, this is where we end up into, right. We end up into the right hand side, so you can algebraically you can solve it, and this is exactly same as there of pk plus 1. So we have established that if pk is given, pk plus 1 is true. Any question till this moment? So this is usually the simplest possible example on induction which we start with, and this clearly demonstrates all those important requirements which we have to establish. P naught has been established, and then we have established this this implication. So if no question, yes.
Sometimes go like if I prove pk is it's harder to find pk plus 1. Is it okay if I can prove pk minus 1?
So, in that case, you will be like starting with pk minus 1, and you will be establishing pk. That's equally good. And we'll see another version of this whole thing as well in a while. Okay. So if there is no case, let's do one more example. Sum of first n positive integers, n positive odd integers is n square. This is the kind of stuff which you had established, you had proved जब आप कर रहे थे, what do we call it, sequences and summations वाले time पे, and like using those proof techniques as well. So but over here this is the kind of stuff which you want to do using induction. So can you try to rewrite it in the somewhat similar format as we saw in the previous example, so that there's a mathematical expression, we have a left hand side, we have a right hand side, and then we can move on. How do we notate an even integer? An even integer 2n, an odd integer 2n minus 1 or 2n plus 1, right? Both are equally good. So 2n is even, so next and previous both of them are going to be odd integers. So what we do is that we run a loop from 1 to n, and 2i minus 1 is 2i is always even and 2i minus 1 is always odd, and sum of the first n odd integers is n square, right? So n square is coming from the given statement. This is how we formulated that linguistic statement in the form of a loop. And then we have to bound or quantify n, that over here when we are saying positive integers, then n belongs, we are talking about for all n who belong to z positive. Okay, so let's try to apply the same sequence of steps we have just seen. So what will be the first step? We need to establish our inductive basis or base case. So that will be for, because I is starting from 1, so we'll be doing it for we'll be plugging in 1. So loop will be running one time, from 1 to 1. So left hand side will be 2i minus 1, I is 1, so it's 1, and right hand side is, because n is 1, so 1 square is 1. Okay, so this is how it will be looking like. Okay, what will be the next step? Sorry? Yeah, so we have to now, the next step is this implication, right? So this thing is given, pk is given, and based on the given the given condition, we have to demonstrate its consequence. So our assumption is, over here we are using n, so it's equally good you use n or k, some variable. So we are saying that assume that Pn is true. So if Pn is true, then this loop is true, and we have to establish this thing for n plus 1. So what yes? 2i plus 1. So sorry, say it again.
हम जो हमारी थ्योरम है उसके अंदर लिखते हैं 2n plus 1
2i plus 1. Yeah.
वो भी एक ऑर्डर होता
Yeah, yeah.
है उस तरह तो ये बेस केस प्रूव ना हो तो अच्छा है
ओके, फिर आप i की जो स्टार्टिंग एंड एंडिंग पॉइंट्स है ना, क्योंकि अगर अब 2i plus 1 को करें तो i की पहली वैल्यू क्या होगी? या नहीं ओके, i की फर्स्ट वैल्यू विल बी 1 if you keep the summation same. So 2i will be 2 plus 1 is 3. So you're not starting with the first first odd integer. So the claim was, if you go back to the statement if you are trying to formulate over here is the sum of first n positive odd integers. So 1 has been missed in that formulation. So if you have to write it as 2i plus 1, then you need to start from 0, right? So आपका जो starting index है, loop का counter है, that has to start from something which is appropriate for that. Okay. So what we do is that we do the same thing which we have just done for what? For the previous proof. So we separate the last term. So this loop is running from 1 to n plus 1. So we separate the first n terms. Why we are separating them? Because we know their answer. And we keep this last term as separate. So last term has to be 2i minus 1. So there is 2 into n plus 1 minus 1. So this thing is representing the last term of this summation. And the first part, this summation is substituted with what is given through inductive hypothesis. So this is n squared because this is sum of the first n odd integers. So if we solve this whole thing, we end up into n plus 1 whole square. Okay, make sense? Any question or concern till this moment?
Sir, I have a different question.
Yeah.
So before algebra, is there any way to prove these things?
Honestly, I don't know. There would have been some stuff like the kind of proof techniques which we studied like previously. Induction is one of the because it's a matter of history, right? So before algebra, I don't know whether induction was in place or not, but people would have been doing some sort of logic has been there for quite long. Its life is much longer than life of algebra. So probably there would have been some maybe intuitive or some other ways of doing things. Okay, so somewhat like the kind of stuff which you call direct proof, or those terms might not be in place, but people would have been doing certain kinds of proofs. Okay. Okay, let's do this one now very quickly. Sum of first n powers of 2 is 2n minus 1. So first n powers of 2, so we'll start, what is the first power of 2? Is 2 raised to the power 0 is 1. Because we are starting from 0 in the power, so I is starting from 0 and we are interested in first n powers, so counter is starting from 0, so it has to go up till n minus 1, and the answer is 2n minus 1. So this is how it will be looking like, and because over here it's not very obvious in the statement, but that's what we meant by small n. That has to be an additional number, a positive integer. Okay, so on the basis side, what we do is that left hand side will give us 0 and right hand side will give us 0, because the loop will not be running even a single time. So the global total wala jo variable hai, there is 0, nothing is being added over here. So left hand side remains 0 because I is starting from 0 and n minus 1 is 0 minus 1. So loop wali jo condition hai, that is false at the start. So left hand side is 0 and right hand side is also 0. Yes?
Sir, upper limit n minus 1 क्यों है? n क्यों नहीं है?
Because our statement was that first n powers of 2n, right? So our first power 2 to the power 0 is 1 because we started with 0 in the power, so I is starting from 0. So 0 to n minus 1 count is n. So this summation, this even loop, this is running n times.
So can we just start with 1?
Okay, if you let's have a look at the base case. Like if you start with 1, so it will get immediately violated, right? Because if you plug in 1 over here, so how many times loop will be running? 0 times. So left hand side will be 0, and if you plug in 1 over here,
But that wouldn't that run for n?
sorry.
Wouldn't that run for n?
So the number of times loop runs will remain same. The point is that what do we call it? When we say first n powers, so what we are doing is that 2 to the power 0 is 1. That's where we are starting from, right? So this has to be somehow given over here, right? That where is n is starting from in order to quantify that whole statement completely.
So can we not just write 1 to n, sum from 1 to n?
Okay. If you write over here, okay. So let's just plug in things, right? So what is the first value of I? So there are two kinds of I which we are talking about. One is the one which is given on slide, so it's 0, 1, 2, and so on. The one which we are starting with is, so let's like keep it finite, 0, 1, 2, 3, and 4, right? So the next one is the new I, let's call it I prime, which you are suggesting that is starting from 1, right? So that will go up till 1, 2, 3, 4, 5. So it's very obvious and intuitive that if I take powers of 2, so the answer will be different, right? So then the right hand side won't match. If the right hand side, so in that case I need to modify the right hand side as well. So even if the given statement is not true, so then like so if the given statement is not true, it's not guaranteed that it will fail on the base case, but at some point it has to fail because there was an and in between two conditions in order to make the whole thing true. So it has to be held true for both of the situations. If any of those situations is false, our entire statement becomes false.
So when we say that n belongs to natural numbers, and when does it belong to positive?
When it belongs to
Positive.
okay, so if it is like so what we do is that n is like natural numbers are actually relatively poorly defined. So sometimes we include 0, sometimes we don't include 0. So z positive is a relatively better definition because we never include 0 over there. So that always starts from 1. Right? So in some of the examples you might have seen that we are starting from 0, in some of the examples we are starting with 1, so z positive that way. So if we are clear that we are talking about something which is non-negative, then we'll start from 0. Right? If you're talking only explicitly about positive things, then we'll start from 1. Okay. So in our so this step has been done like very quickly, right? So what we have established over here is that we actually are establishing from something true from 0 to n minus 1 plus 1. So that becomes n, and that is summation of the inductive hypothesis plus the last item, and then we solve it. We have many more examples to do on induction, so have a quick look. If you are like, if you are okay with this last line, then we'll move to the next example. What is this part? If you look over here, so this is what was our IH, inductive hypothesis. Inductive hypothesis plus the last item is 2 raised power n because our original loop is running from n, and if we solve, so this part is 2n minus 1. And so 2 times 2n minus 1, powers will be added up, so 2n plus 1 minus 1 will be the answer. Yes?
But we have taken the basis step for n to be 1.
We have taken it as 0, right? So I is starting from 0, so we plugged in 0 over here in place of n. So P naught means that wherever is 0, we are just like plugging in 0 over there.
So the basis step always has to be in 0.
It depends. Like so if the statement is explicit about positive integers, then we'll be doing it for 1 as we did in the previous example. Right? And in certain cases we'll be saying that this thing is true for n greater than or equal to 2. Then our base step will be 2. If says it has to be true from like n is greater than or equal to 100, then our base step will be at p100.
So we won't define in terms of the loop has to run once.
Yeah, exactly. So that is like intuitively there is something very much equivalent to that first domino in our pile of dominoes. right? So because the first one has to fall, and that's what we have to demonstrate.
How is that 0? Summation 2I plus 1.
This one. So how many times this loop will run? 0 times. 0 से -1 जा रहा है in the positive sense. The loop वाली condition is false at the start. So our I is starting from 0. Is I less than equal to -1? Condition is false. Just open up this summation, write a for loop for this. So this will be looking somewhat like this. Which limits? So this is for I is 0, I is less than equal to -1, I plus plus. And this is what is written inside the summation. So the loop is false at the start. But because this is a summation, we know from our programming background that there has to be some sum which has been initialized with 0. So if nothing has been added up there to that thing, so left hand side is 0. Go ahead. Which limits? No, it's going in the positive way from 0 to -1. So step size is default step size is 1. Right? So if you change that thing, then you need to write that thing explicitly somewhere inside your loop, no? In the notation. So default step size can be is only +1, but you can always change that, right?
तो उसके नोटेशन को देकर हमने इस समीशन वाले फॉर्मूला में डिफॉल्ट को चेंज करना स्टेप साइज.
I think there is something which you need to write after this thing, right? So comma something like this. Right? So some of the actually of the teacher writes it on top of that as well. Yeah. So but like in mathematics, like that's the programming point of view, right? From mathematical background, when we write it without step size, the default size is 1, +1. Okay. And if it confuses you, then you can always write that explicit thing. This is +1, right? So it's not running in the reverse order. That is guaranteed.
So if I take the upper limit of this equation to n, isn't it still valid?
If the upper limit is n,
फिर भी वो same बात होगी.
if the upper limit is n and lower limit is, yeah.
तो फिर से
Yeah. So it's just a like matter of so one quick way to clarify this last statement is that you can plug in k over here in place of n, right? So the point is that so if I try to open up this last line, your question on the last line, right? Yeah. Okay. Yep. I is 0 to. Yeah. No. What does that mean? That means that you are running the loop one more time. Which means you are adding, because if this thing is 0 and this is n, so what does that mean? That loop is running from 0 to n instead of 0 to n-1. So if you run your loop once more, so some new thing has to come into your sum. So if left hand side will change, if left hand side changes, then right hand side has to change somehow, no? फिर हमारा ये वाला formulation will be incorrect then. Okay, so our next example is number of, so this is a slightly different example. Number of subsets of an element of an n element set is 2 raised power n. And this is what probably we are able to recall from our basic set theory concepts, that given a set whose size is n, so if A is a set, its cardinality is n, then what will be the cardinality of power set of A? 2 raised power n. And what does the statement say? Number of subsets of an n element. So what is the power set? Power set is set of all subsets, and the total count is 2 raised power n. Okay. So so what we do is that we start with the smallest possible set whose size is 0. Can there be a set whose size is 0? Null set. And what is size of the power set of null set? So cardinality of this set is 0, and power set of this set is equal to what?
1.
So that will be written somewhat like this, right? So that contains that set as one of the elements. So the number of elements in the power set is 1, right? So the cardinality of this thing is 1. So there are 0 elements, n is 0. So the number of subsets are 1, and if you look back at the given statement, that number of subsets in a 0 element set is 2 raised power 0. So base case establishes that given statement. So the first part of our that conjunction is true, that it is true for P naught. So our inductive hypothesis is that, so this is now slightly tricky, right? So the way, because we have been we can't model it like very elegantly in terms of mathematical or algebraic formulations. So what we're doing is that we assume that it is true for any set which contains n minus 1 elements. So if a set contains n minus 1 elements, how many what will be the size of the power set? If set A contains n minus 1 elements, size of the power set of that set is going to be 2 raised to power n minus 1. Is everyone okay with this thing? Okay. So what we do is that, now there are two ways to do it, right? So we assume that this is our inductive hypothesis. So if our inductive hypothesis is that the set contains n minus 1 elements, and so this thing is given. If there is a set of n minus 1 elements, size of the power set is 2 raised to power n minus 1. So what we need to establish over here is that, what do we need to establish over here? That if we add one more element into the set, if we add one more element to the given set whose number of elements is n minus 1, so the new set hoga, that will be containing what? So the given set, we take its union with a small set which just contains one element x, and we call it A prime. So A prime की cardinality कितनी हो जाएगी? Cardinality of A is n minus 1. We are adding one more element, so cardinality of new set is n minus 1 plus 1, which is n. Right? What should be the cardinality of its power set? That's what we have to establish. What we have to establish is that it has to be 2 raised to power n, based on our baseline is the inductive hypothesis. So if you look at PA, power set of A, that contains many subsets, right? Number of those subsets is 2 raised to power n minus 1. Is everyone with me? Some people are not. Okay. So a quick question. जो PA है, the power set of A, does any subset over here contain X? Does any subset contain X over here? No, right? So just give me a while, I'll take your question. So so there are two kinds of subsets now. There are some subsets of A prime that don't contain X. What are these subsets? These are exactly those subsets which were members of P of A, and their count is 2n minus 1. Right? Now all those subsets have been replicated over here, have been placed again over here, and what has happened with them? That in all those subsets we have inserted X. So X is the new element which has become part of A prime. So in all those previous subsets which were here, none of them contained X. So we are inserting X in all of them. If we are inserting X in all of them, so these are the subsets that contain X. Now power set of A prime जो है, that has two types, two kinds of subsets. Subsets which do not contain X and subsets जिनके अंदर X है. इनका count कितना होगा? Because these are exactly the same subsets. We have just inserted X in every subset. So their count is 2n minus 1, and we are done. किसका? Yeah. So now this PA वाला जो है, इसके subsets कितने हैं? ये वाले plus ये वाले. Okay. Sorry. Subsets that contain X 2n minus 1 क्यों है? Okay. So where do they come from? They have to come from capital A and mix of X. So all those subsets which do not contain X have already been listed over here. So all subsets which are like remaining part, all of them have to contain X. But X के अलावा there is no new combination which has to come into play. So all previous subsets are being represented again, so their count will remain same. So the only new thing which will come into play is X. Right? So you had a question?
Sir, I पूछा था, can't I just say कि since A prime contains all the sets of A and all the sets given by X, so that's 2 power n minus 1 and 2, why does it add them?
Can you please say it again? So A prime contains all previous elements.
A prime contains 2 power n minus
No. A prime is the original set. A
contains 2 power n minus 1 power sets, subsets,
okay.
and the new row contains 2 power 1 subsets. So that's 2.
No, but like once we have put X into the original one, in the original set A, and when we are making all possible subsets, then that X will come at many places. So it won't come at one place. Are you getting my point? So if we have 5 elements and some 6th element come into play, so all subsets will be impacted with that, right? So if you like add these two cardinalities, 2n minus 1 and 2n minus 1, so what will get? So this is 2 times 2n minus 1, powers are being added up, so this is 2 raised power n. Yes? Okay, we are proving the base case that the set is empty. So if the set is empty, then its cardinality is 0. The first line on that blackboard, right? So power set में कितने items होंगे? 1, right? So that's what we know from the characteristics of power set, right? So and the right hand side also matches with that thing. If n is 0, if size of the given set is 0, 2 raised power 0 is there. That, right? So that is the only one subset in the power set. Yeah. No, A prime is just another notation, right? So it's not complement. Thank you for pointing out. We can like make it something different, right? Okay, sorry. Yeah, go ahead.
ये वाली चीज subsets that don't contain X.
ये वाली?
वो ताकि board पे
Okay, so this is what when we have like this new set A prime, we are taking its power set. How many elements are in A prime? N. And what should be the size of the power set? It should be 2 raised power n, but that's what we have to establish. That's what we have to establish, right? And the way we have been establishing over there or here is that we are, so what does this contain? This contains all subsets of A prime. So all subsets which were there in A, they have to be there because they are also subset of A prime. If they have to be there, those are these places. They do not contain X. So what is the number of new possible subsets which you can generate out of it? So there is only one new element which has been added in A prime. So what we do is that all new, whatever are the possibilities, they'll remain exactly same. So in all those subsets, we'll just insert X, the new element, and the count will remain same. And both of them are part of power of A prime. So we add up their cardinalities, and so this should have been cardinality. So we add up their cardinalities and end up into 2 raised power n. So if you look over here quickly, so it more or less says the same thing, right? What we've done on the board. Yep.
सॉरी मैं उसको दोबारा कर रहा हूँ, लेकिन इन समरी यही कह रहे हैं ना कि अगर हमारे ओरिजिनली n-1 थे, आपने x डाल दिया तो अब n हो गए. अब आपकी दो पॉसिबिलिटीज हो सकती हैं सबसेट्स में, ये तो x है या फिर नहीं है, और उसकी जो है डिफरेंट पॉसिबिलिटीज है, 2n-1 2n-1 बन रहा है. तो हाफ जिनके अंदर x है और हाफ जिनके अंदर x नहीं है.
Yeah, and where is the 2 raised power n-1 coming from?
Number of subsets जिनके अंदर x है.
That is coming from IH, right? Inductive hypothesis. Yeah. Exactly. Yeah, true. Okay, a quick question, अगर आपको सही समझ आ गया या नहीं आया, तो एक मैंने गड़बड़ की है probably ना, and that is that I have added empty set on both sides. Did I add empty set twice over here on the board? Right, so empty जो था उसमें x आ गया, there is no more empty. Okay, और जो पूरा सेट था यहाँ पे, because the whole set is subset of itself, उसमें x आया तो that has become the whole set of जो new वाला है, prime वाला है. Okay, thank you. Okay, a slightly different kind of example is that an ATM will, with only two kinds of bills, one is $3 bill, other one is $5 bill, can generate any amount greater than or equal to 8. Is it possible वैसे? So first we need to convince ourselves intuitively that an ATM has only two kinds of notes or coins, which are like $3 or $5, and can it generate any amount greater than or equal to 8? So if it is 8, what is the base case over here? Base case is 8, right? The smallest amount which can be possibly generated, that is 8, and because we have 3 and we have 5, so 3 plus 5 is 8. So base case is true.
Do we always have to have a $5 bill?
No, it's not necessary. So those are the possible options, right? No. So there is no other like restriction कि आपने $3 को लाजमी use करना है या $5 को लाजमी use करना है. So that's your choice. But in this particular setting, so is everyone okay? The base case is very obvious. So what could be the other situation? So the problem is that if so, what is the problem? If you think of this whole thing in terms of implication, where is the implication? So pk is given, k has to be greater than or equal to 8. That means pk का true होने का क्या मतलब है कि pk is true, that means any amount which is greater than or equal to 8 can be generated through कौन से bills, $5 and $10 वाले. So क्या k plus 1 हो सकता है हमेशा? K plus 1 is the next immediate amount. So base case is very obvious. So if the ATM can generate any amount of $n, then we have to demonstrate that it can also generate any amount which is of n plus $1 worth. Okay. The output contains, so there are two cases. One is that it contains $5 value amount. The other one is that it does not contain $5 value amount. So if the output contains $5 value amount, so how many $5 value coins are there in the sum?
5.
At least one. No, just look at the case 1. So what does this statement say? It says it contains $5 value amount. So the baseline is that we are not sure about more than one possibilities. $5 value coin might be repeated many times, but at least one is there in case 1. So if it is there, then the situation is very simple, and that is if it is false, then we can like disprove something, no? Yeah, a counter example means that the statement is false and we are going to demonstrate something that see it's false. Hai na? Yes?
Sir, is this question saying that two prime numbers p1 and p2 can produce any number greater than p1 plus p2?
No. So we're not sure. Prime numbers वाली restriction यहाँ पे इसलिए नहीं है कि यहाँ पे there are two fixed numbers 3 and 5. So we can't generalize it to two given prime numbers. उस तरह की situation के लिए we can bring in a counter example very quickly. तो अभी हमारे पास 3 and 5 are fixed, right? Okay, so okay, let me try to say it again. Base case is very obvious. Any question on the base case? So our assumption is, our inductive hypothesis is that pk is true. That means that any amount of k dollars or n dollars can be generated using these two kinds of bills. Now there are two situations. One situation is that it can be generated whatever is the output, that n has to contain a $5 bill. Okay, this is one situation, right? And there are like many practical situations where this has to be true. For example, if we have to generate $10 वाली amount के लिए we need to have at least one 5 वाला ना, and actually we need two 5 वाले, otherwise 3 से 10 generate नहीं होगा. Okay, so if it contains $5 वाला bill, what does that mean? How we can move to the implication वाला part? Sorry?
Must contain at least one $3.
Yeah. We don't know. So the only thing which we know is that n has to be greater than or equal to 8. It contains a $5 bill. A 5 does not mean exactly 5. Can be more 5 वाले भी or cannot be. Okay, so 2 5 वाले भी हो सकते हैं to make 10.
हम इसको इस तरह सोच सकते हैं कि जो remaining होगा n-5, that is either a multiple of 3 or a multiple of 5.
That is not guaranteed because 8 is not a multiple of 5, 8 is not a multiple of 3.
No, but 8 के अंदर अगर एक $5.
Yeah, but they are being added up, right? So 8 is not multiple of 5. 5 plus 3 है ना?
No, but उसको remaining 8 minus 5 get
8 minus 5 को okay या उस तरह की कुछ चीज़ सोच सकते हैं, but that makes some sense. Yeah. फिर हम गलत on what?
$11 निकालने मुझे।
$11 निकालने हैं तो take 1 5 2 6 वाले 5 plus 6 is 11 और 4 3 वाले ले ले 5 को इग्नोर कर दें 13 2 5 वाले plus 1 3 हाँ x plus 5 के what is x?
X is n dollars, so n equals to x plus 5.
Okay, so and you are bringing in another variable, right? So you're saying that n equals x plus 5, you are right. So, and from here we have to generate what? Our task is to generate n plus 1, but we are not allowed to use anything other than 5 and 3. So what Abdul Basit pointed out was that, what was that thing? He said that add 2 3s and remove this 5 which is there, right? So 2 3s को add करेंगे तो what is that? और 5 करेंगे तो difference is 1. So we are adding 1 on the right hand side as well. So this will become x plus 5 is there, and we are doing what? We are removing 5 and we are adding 6. So this gives us what? X plus 6, which is just next number, right? So this is case 1, but we are not sure that in all cases $5 will be there. So if $5 is there, we just take away that $5, substitute that with two $3 वाले bills, and we are done. Two $3 वाले bill का मतलब क्या है कि 6 is being added, 5 is being removed, और net impact is 1.
Like, how do you do that in an ATM? वापस ना डालें।
क्या?
वापस ना डालें 5 में।
Oh, ATM has to decide that thing, ना? कि उसके we are just demonstrating कि can it generate that thing or not. So the only thing we are demonstrating is that it can generate. That's not something we are not doing any transaction with ATM. We are saying what is the capacity of the ATM. There's only like those two kinds of dollars. Can it generate any amount? That's what we are trying to demonstrate. It cannot, because n is greater than or equal to 8. How can it generate 1? Oh, forget about this liberalization. ये तो मैंने उनकी कहने पे लिख दिया था ना. अब intuitively does it make sense? देखो आपके पास कोई amount है and that contains $5. I'm not interested in कि exactly amount कितनी है, but उसमें $5 है तो 5 से तो बड़ी ही होगी. 5 से छोटी हो सकती है वो? नहीं हो सकती, right? Because that contains $5. So now I have to add 1 into it. I have a pool of $5 and $3. What I do is that I subtract that 5 from your pocket with your permission and give you two bills of $3 each. So what will be the net impact in your pocket? Pocket plus plus. उसमें 1 increment हो गया ना? Right? But this was one case. Any other question on the first case? So what about the next one? If it does not contain any $5 bill, what does that mean? Then it must have to have at least $3, or 8 वाली capacity is now ruled out, because if there are 2, अगर 5 वाले तो है ही नहीं, इस absence of $5 वाली चीज़ absence है ना, तो 6 तो हो नहीं सकती because that violates this thing, right? So it has to have at least $3 वाले bill. What does $3 वाले bill को add करें तो कितने बनते हैं? 9. Very good, right? So because those, if $5 वाला bill is not there, then it's guaranteed that there it has to have $3 वाले 3 bills. Their sum is 9. Remove that 9 and add 2 $5 वाले bills. Yes? Make sense? Okay, now your turn. So do the ICPs one by one, right? So like I should have inserted a pause over there, but so do the first one only. So this is very similar to the one which we have just done. What is the base case? P10, but it says n is greater than or equal to 12. P12 is the base case, so can we generate 12 wala? 4 times 3 is 12, so 4 times 3, then it's established that we won't be using any $7 wala bill in the base case. Okay, and then do the similar kind of stuff which we have just done over there. What is given is that Pk is true. This is our inductive hypothesis, which means any kth amount can be generated using the bills of $3 and $7. So what should be the first case? So if the bill, so you can go either way, right? So think of both of the ways, which one is more convenient and quick to do. कि हम $3 को साइड पे रखें या $7 वाले को साइड पे रखें? Case 1 is that K does not contain $3 wale bill. So if it does not contain $3 wale bill, what will be the smallest amount which you can generate without $3 wale bill? 14, because we have to meet that baseline, right? So our n has to be greater than or equal to 12. So that K has to be then at least 14, and two $7 wale bill must have to be there. So if it does not contain, this implies that K contains at least 2, maybe more than that. So it contains at least 2 bills of $7 each. And what should we do next? Remove those 2. If you remove those 2, so what is the amount which we are removing? 14. And what we have to insert there? Because K plus 1 we have to insert 15. So we'll bring in $3 wale 5 times. 3 5s is 15. Okay. And what will be the case 2? That it contains $3 wale bill at least once. उसको अब करें आपको भी. ओके केस पिछले वाला 8 और 3 वाला समझ आ गया था, वो वाला भी समझ नहीं आता. ओके सो अभी वाला केस 1 समझ आया. लेट्स डू दिस केस 1 अगेन. ओके सो आवर टास्क इज कि आपके पास कोई भी अमाउंट हो n विच इज़ एटलीस्ट 12. उस n को हम बना सकते हैं यूजिंग 2 काइंड्स ऑफ बिल्स. ठीक है, इट्स जस्ट लाइक अ पूल ऑफ नोट्स. आपके पास बहुत सारे थ्योरेटिकली इनफाइनाइट नोट्स पड़े हैं, उन सब की टाइप या $3 है या $7 है. सो उनको किसी भी कॉम्बिनेशन में मिला के देयर इज़ अ पॉसिबिलिटी यू कैन जनरेट एन अमाउंट. इट सेज एनी अमाउंट कैन बी जनरेटेड. सो n इज़ ग्रेटर देन इक्वल टू 12. ठीक है, तो बेस केस वाली समझ आ गई थी ना. अच्छा, अब उससे अगले वाला ये है कि नाउ व्हाट यू टू डू इज़ कि अज्यूम कि कोई अमाउंट k है विच कैन बी जनरेटेड यूजिंग दोज 2 काइंड्स ऑफ बिल्स. इफ़ इट इज़ ट्रू, तो अब उस k में क्या हो सकता है? इट मे कंटेन $3 वाले बिल और मे नॉट कंटेन. इफ़ इट डज़ नॉट कंटेन, तो बाकी सारे बिल्स कितने होंगे k में? 3 वाले अलाउड ही नहीं है, उसमें 3 वाले यूज़ ही नहीं किए. सारे 7 के होंगे. वो कम से कम कितने होंगे 7 वाले? एग्जैक्टली 12 से नीचे नहीं हो सकते ना, 1 नहीं हो सकता, 0 भी नहीं हो सकता. अदरवाइज अमाउंट विल फॉल बिलो दिस थ्रेशोल्ड. सो दे हैव टू बी एटलीस्ट 2. 2 से ज़्यादा भी हो सकते हैं इफ द अमाउंट इज़ लार्ज. फॉर एग्जाम्पल इट इज़ 70, तो दे विल 10 7 वाले बिल. बट द टास्क इज़ कि हमने उससे नेक्स्ट इमीडिएट k plus 1 बनानी है. ठीक है, तो अब 2 7 वाले तो गारंटीड पड़े हैं ना, तो जस्ट रिमूव देम. इफ़ रिमूव देम तो कितना माइनस होगा? 14. तो और 5 बिल्स 3 वाले डाल दें तो कितना ऐड होगा? 15. तो विच इज़ 1 मोर देन बट वी हैव रिमूव्ड. तो यू हैव जनरेटेड k plus 1. और यही एनालॉजी हमने यूज़ की थी पिछले एग्जांपल में भी, और यही एनालॉजी आपने यूज़ करनी. इसके जितने भी केसेस बनते हैं, ज़रूरी नहीं कि एक ही केस और बने, जितने भी केसेस बनते हैं तो कीप ऑन मेकिंग देम, राइट.
यहाँ पर हमने किया, हमने n हमारे पास आ गया x plus 14 और n plus 1 जाने के लिए हमने कहा कि हम +7 और -6 कर देते हैं.
नहीं, +7 नहीं किया था, +7 -6 कर देते हैं. ओके, लेट मी थिंक. if there is like if it contains at least 2 7 bills, तो उनमें से आप एक रिमूव कर रहे हैं. नहीं, आप उसमें से एक रिमूव कर रहे हैं, तो यू आर सब्ट्रैक्टिंग 7, राइट. यू आर नॉट एडिंग 7. 7 वाला तो रिमूव हो रहा है ना. सारे 7 वाले पड़े थे, तो 7 वाला रिमूव करेंगे ना, तो माइनस होगा ना, 7 प्लस तो नहीं होगा.
ठीक है, लेकिन n plus 1 कैसे होगा?
तो हम एक से नहीं बनेगा ना. बट वी नो कि देखो, वर यू ओके विद दैट थिंग कि इट हैज़ टू कंटेन एटलीस्ट 2 $7 वाले बिल. तो वो दोनों निकाल दें. तो दोनों निकालेंगे तो कितनी अमाउंट माइनस हो जाएगी? 14 और हमारा टास्क क्या है, हमने ऐड कितना करना है उसमें 1 का डिफरेंस रखना है, तो 14 रिमूव किया तो ऐड क्या करना चाहिए 15, एग्जैक्टली 15, ना उससे कम ना ज़्यादा, क्योंकि n+1 तब बनेगा ना। 15 कहाँ से आएंगे? अच्छा, so what I'm going to do is that okay, the next two ICPs and they are like very similar to the stuff which we have done in the previous examples. Those are like those algebraic formulations, and you have to establish these things, sum of cubes. You have to write left hand sides, right hand side is given, write the left hand side that is given, and that is going to take a lot of time. So what I can do is that we can skip those two ICPs, and so like complete them once you go back. They are ungraded, we won't count them in your ICPs, but otherwise we'll be spending rest of the 1 hour on those 3 proofs, right? But if you get stuck, so most probably we are going to meet in the next session as well, so we can have a quick discussion on them, right? Okay, so now there are like this is somewhat like applied side, because majority of you are CS majors, majority there are some math majors as well. So hopefully you'll be taking these algorithm and data structures courses in the coming semesters. So there is something which you'll be seeing this term loop invariant again and again in algorithms and data structures course. So what we do is that what does this code do? Without looking at the code, it is written on the top, right? Find max. Agar wo readable hai to. So this is a simple loop which is running how many times? N times, and what does it do? It finds the max, so it assumes that max is 0 and these are positive integers. So after scanning the whole array, eventually it will be able to locate max, and then that can be returned by that function find max. So, and this algorithm, this function claims that whatever is max of A, that will be eventually returned in this variable max. Loop invariant is a proposition that remains true throughout the loop, right? So if you look at the claim again, it says max is the variable which is storing the largest number, right? So if this is the array, so it is running from 0, 1, 2 up till some n or n-1, it's the last index. So max is something. So if you look at the code, which is like very obvious, so if you're here, we haven't started the loop yet. What is max? 0. When we start, we go element by element, right? So when we've reached here, what is the max? So if we've reached here, so max is the max of this part of the array. So max value condition remains true even on the subarray. The ultimate goal is that max variable will be containing the largest element of the whole array. But if you like break it down into pieces, if it is k, if you look over here like k minus, agar yahan tak aap isko chalaएं, it will be containing the largest element in this part. If you run it till this moment, it will be containing the largest element in this part, and so on, and it will be true till the base case. So if the size of the array is only 1, so max will be that number, right? So loop invariant is a proposition, is a condition, is a situation which remains true throughout the loop, and that's what is the claim, right? So this is what is loop invariant, and so it's true at iteration 0 and it's true later on. So people use induction in computer science to prove that certain characteristics of an algorithm remain true throughout the algorithm, right? So this is the simplest possible example of applying loop invariant, and we can prove using induction, and you'll be using induction probably in your algorithms course, is loop invariance ko, how you theoretically prove that thing, because for large algorithms or like slightly complex algorithms, we cannot demonstrate them by just executing them, right? So sometimes execution is possible, sometimes execution इसलिए भी impossible होती है that your algorithm or task is like mission critical, and you have to establish its correctness using theoretical proofs beforehand, right? Otherwise you may not take the risk to just run it. Okay, let's go through this proof very quickly. N into n+1 is an odd integer. So is this proof correct? Any blunder or mess up which would have been made over there in the inside the
n equals 2 times 3 is 6, 6 is
Okay, so anything wrong, n into n plus 1 is an odd number, this is our assumption. We add 1 into it, we add 1 here, it becomes n plus 1. We add n plus 2 over here, it becomes this thing, we open it up, and what is this is through inductive hypothesis, we know this is odd, and this is even plus odd, so hence it's odd. But she's disagreeing with that thing, and what is the disagreement?
If we take n equals 2, 2 times 3 is 6, 6 is not.
She's saying that if n is 2, n plus 1 is 3, 2 into 3 is 6.
Your hypothesis is wrong.
Then the hypothesis is wrong. And this is like one exact counter example जो आपने की हो, there is another counter example. So what is wrong in the proof? Huh? Excellent, right? So we missed the base case. So it is not even true at the start. And we just assume, so if the base case is missing in this whole story, so how did we start with? We didn't care about that first tile which was vertically placed. And we didn't know कि वो hit होगी भी, वो हिलेगी कि नहीं हिलेगी, गिरेगी कि नहीं गिरेगी, and we just started all of a sudden from somewhere in between, and we established something true which is actually not true, right? So base case is missing, and we should be quite careful in all those kind of statements, right? वैसे भी two consecutive integers में से one has to be even. If one is even, their product is even, so the statement is wrong. But the wrong statement is being established just by missing the base case. And that might be an overlook kind of thing as well. You might not be like taking care of that thing because that might be like the simplest step in that whole story. Okay, have a look at this proof. It says that loop is running from 1 to n, and this is equal to this right hand side. It's true, formula is true for n is equal to 1, then inductive hypothesis is taken, and everything is proven true. But something is wrong. What is wrong, Bessie? Let's say add first few numbers, right? Do we end up into this thing? जो लिखी हुई है. So if I add first 1 plus 2 plus 3 plus 4, right hand side क्या कह रही है? This n is 4. 4 plus half is का square divided over 2. So this is what? 4 3 7 2. This is 10. This is 4 and half is 9 over 2. Is it 9 over 2? Oh, 9 over 2 and square n over 2. So this turns out to be 81 over 4, 8. This becomes 8. 4 into 2 is 8. So this is like this is little more than 10 point something, right? So the statement is actually not correct. Base case गलत है, very good, right? So the something which is wrong is that we said that formula is true for n is 1, but it's not true. Left hand side is 1 और right hand side क्या है? Base case के लिए left hand side is 1. We are running the loop once, or if you plug in 1 over here, this is 3 over 2, 9 over 8. So 1 point something, right? So this is actually the right hand side is n plus 1 over n. ऐसे ही है ना? या जो भी है. But like the point is that we made one like incorrect claim over here and we ended up into this thing. Okay, now this is an interesting example. Okay, so what is the statement? All horses are of the same color. Anyone who does not know what is a horse? What is a horse? Okay, let me show you the picture. These are the horses, right? So if you didn't know, these are the kind of things we are talking about. So the claim is that all horses are of the same color, and we are going to prove this thing using induction. ठीक है, अब जिसको पता नहीं है, that guy might be an exception. जिसको पता नहीं कि horse क्या होते हैं, जिनको पता है वैसे, is this statement true? All horses are of the same color. नहीं, counter example is कि मैंने देखा था कि there were 2 horses which were different colors, right? You are not horses, right? Okay, any set of n horses. Okay, so the now statement has been like made like bit mathematical, that there are any set of n horses have the same color. So the claim is Pn is true. A single horse is the same color. Base case is very obvious, right? So if n is 1, एक अकेला horse है तो उसका same color होगा ना. It will match with itself. Okay. So inductive hypothesis is that any horses have, if n horses have the same color, then we have to establish that Pn plus 1 is true. That's what we are going to do. So how many horses are there? Oh yes. Yeah, hold on. Right. So there is the smallest number of horses, right? That's why we took. So n के ऊपर like there was, okay, n could have been 0, तो फिर color applicable ही नहीं होगा. So the smallest number which we could pick for n is 1, right? But you are actually getting to the solution. That's why I stopped you. Okay. So these are n plus 1 horses. So the claim is that first n horses are of the same color. Why? Because that's our inductive hypothesis. Our inductive hypothesis was that n horses have the same color. So first n horses have the same color, and then we applied the same inductive hypothesis on the last n horses, and then there is an overlap in between, right? So over here, this horse has the same color as these ones, other than the last one, according to the previous version of inductive hypothesis. And then this horse, जो हमने पहले छोड़ा था, this has the same color with the previous one except this one. So hence, like if there is an overlap, n plus 1 total थे, first n and last n are true because of inductive hypothesis, and hence n plus 1 horses have the same color. Okay. और आपको जिन लोगों ने घोड़े देखे हुए थे पहले, तो वो कह रहे थे कि they are not of the same color, all of them are not of the same color. So हमें लग रहा था कि statement is false, but what is false in the statement? So this is ICP, but I'm going back to that proof so that you can analyze the proof. I'm coming to you, right? Okay, now you can bring in those horses. Which
This case was wrong.
this cause is not wrong, right?
No, the n should be 2.
Why?
Because we're saying two things are the same, so we're comparing.
नहीं but देखिए हमने कहा था sum of first n numbers is something, और हमने अकेले नंबर को लेकर कहा था कि अपने आप के साथ अकेले ही सम है तो बस वही है, तो हमने उसके ऊपर हमें कोई प्रॉब्लम नहीं था. हमने ऐसे किया था थोड़ी देर पहले. First n integers कहा था, तो we just picked the first number, we added that into a global variable, and we said that is true, so we were okay with that. Why you're not okay about horses?
No, we can write an implication and say that this is equal to this color and that is equal to.
Okay. बोलो. नहीं बोलना. Okay, yes.
सर इसका बेसिकली स्ट्रांग नहीं होगा अगर एक घोड़े के वाइट नहीं है बाहर.
So see, okay, yeah, okay, वहाँ पे तो वैसे ही ना इंडक्शन फेल हो जाती है. आप वाले जो है ना जो ऑब्जर्वेशन है कि वन हॉर्स माइट बी हैविंग मल्टीपल कलर्स ऑन इट, गोल्डन, पर्पल एंड जो भी होते हैं, ब्लैक, वाइट, सो उसमें प्रॉब्लम ये हो जाएगा कि वहाँ पे इंटीजर्स वाली थ्योरी वैसी गड़बड़ कर जाएगी ना, कि प्रोपोर्शंस में हम चले जाएंगे. तो जब हम इंटीजर डोमेन से निकलते हैं इंडक्शन वैसी गड़बड़ कर जाती है. बिकॉज अब देखो ना, अब के एन पी के तक ट्रू थे, अगला इमीडिएट स्टेप इज एन इंटीजर. दैट्स द बेस लाइन वेयर वी आर अप्लाइंग दिस इंडक्शन वाली चीज़ ना. या इसको रिवर्स भी करें तो के माइनस 1 इज़ ट्रू एंड के इज़ ट्रू, दरम्यान वाली जो, बिकॉज इट्स नॉट ऑन द रियल लाइन. सो उसको तो आप अज्यूम करें कि हमने उनको पेंट कर दिया सब हॉर्सेस को विद द सेम कलर, राइट, ऑल हॉर्सेस. सो यू आर लाइक फ्रॉम दैट परस्पेक्टिव डेटा टाइप का मिसमैच वाला, यू आर राइट, बट देयर इज अनदर ऑब्वियस रीजन ओवर हियर, राइट. ये मेरा प्रूफ नहीं, आपका है. ओके, यस, से इट अगेन. 400 घोड़े, या सो 400 घोड़े आर द गिवन जिनको हमने एस्टैब्लिश करना है, ठीक है. तो बट या चेक ये करेगा, दे हैव बीन लाइक they have been arranged in a sequence, they are in one line. Our inductive hypothesis says that is pk, that is given, right? That's not something which we are establishing. pk inductive hypothesis says that pk is true, which means कि अगर 400 हैं तो 400 minus 1 are of the same color. So 400 minus 399 जो horses हैं, like that's a big chunk, that is given to us, that's not something which we are establishing, right? So we just pick the first 399, हम inductive hypothesis को use कर रहे हैं, और ये हमने exactly use किया था इसको थोड़ी देर पहले जब हमने वो ब्रेक डाउन किए थे समेशंस को कि लास्ट एलिमेंट को सेपरेट करें. समेशन में हम लास्ट एलिमेंट को सेपरेट कर रहे थे ना थोड़ी देर पहले, तो उसी तरह के हम काम करें कि लास्ट हॉर्स को सेपरेट कर रहे हैं from the rest of the thing, और जो remaining 399 है, that is our inductive hypothesis. And then we do the same thing for the first horse, उसको अकेला करते हैं, and then we apply, और फिर हम कहते हैं चूंकि वो
I think we're trying to prove equivalence, so we've proved that A equals B. वो पहले 100 horses थे, पहले n horses थे. Then we've also proved B equals to C, that's the n plus 1 to y till n horses. Now we prove C equals B.
Okay, let me try to write it. मैं ये कर रहा हूँ कि let's see, H1, H2, H3, let's say 4 horses हैं, 4 horses हैं, but तो हमारे पास inductive hypothesis is that 3 horses have the same color. So what we do is, because any set of 3 horses is same color, so we see that let this be the set, so they have same color. So let's say they have color C1. Okay, now what we do is that we pick the last subset of 3 horses n minus 1 wala, and we say that this has same color. इसका color क्या हो सकता है? Can it be something other than C1? Not, because इसका overlapping part is already C1 we have established. So if these are C1, on all of them have the same color according to inductive hypothesis, then this must be C1. So hence all of them have C1. जब तक solve नहीं करेंगे break नहीं होगी.
इसका लेकिन converse true नहीं है ना कि if we say 400 have the same color, 399 have the same color, तो उसको अगर opposite करेंगे 399 same color, तो एक हमने add किया, उसका same होना जरूरी नहीं.
Yeah, उसको होना जरूरी नहीं है, but that's what we have to establish, right? That's what we are trying to establish. We are saying that 399 का जो set है, we have just arranged all of them into some row, into sequence. This kind of breakdown is valid because this is somewhat very similar. कि हमने कहा था कि I is a loop running from n 1 to n plus 1. तो हमने इसको कहा था कि we can break it down to I starting from n and last वाले को separate कर लो. And we also said that this is same as first वाले को separate कर लो and loop should run from I is 2 to n. So we are okay with that thing. So we are just separating the first element and the last element from the whole chain of forces. And the reason we are doing it कि n minus 1 के लिए हमारे पास information है, there is given, that is pk, that's something which we are not supposed to establish. हाँ? लास्ट के बारे में नहीं है, लेकिन उसका क्या तुम्हें पता है ना, अकॉर्डिंग टू आवर इंडक्टिव क्या था उससे बेसिस दैट वन हॉर्स हैज द सेम कलर. यस,
जो मतलब आपने वो शिफ्ट है पहले अगर 3 है तो हम अगर वो शिफ्ट आपने में तो वो 2 होना.
क्या से इट अगेन.
So like the base, like the induction hypothesis was like first 3 were true, right?
Yeah.
And now we say like we shift that to last 3.
Okay.
You are saying that needs to be true.
That has to be true because that's what the inductive hypothesis is saying.
That is what like we assume.
Yeah.
हमने जब वो नया वाला ऐड किया, we don't know कि was that.
देखो अगर ये वाली बात false है तो inductive hypothesis is false. Let's read the inductive hypothesis again. Yeah, just give me a while. Where is the inductive hypothesis? Yeah, so inductive hypothesis says that Pn is true. So that means that the first n horses are of the same color, the last n horses are of the same color.
इसमें दो केसेस होंगे. अगर लास्ट फॉल्स सेम कलर सर, अगर लास्ट फॉल्स को नहीं होगा, अगर लास्ट फॉल्स
आपने ब्रेक नहीं करनी है वैसे, बाकी लोगों ने ब्रेक करनी है तो बता दें, अदरवाइज हम बैठे रहेंगे. यस.
So that would be for all n belonging to positive integers. If C of एक solution theory है, if C of I and C of I plus 1 is the implication that says the color of the iron forces. तो वो and आता है, इसमें जब हम एक को proof और जब बेस के साथ लेंगे तो हम एक.
ओके, आपके लिए हिंट है कि आप यहाँ पे पहले मुझे बताने लगी थी कुछ देर पहले, तो सख्त यू आर ऑन द राइट ट्रैक, देन यू गॉट डिट्रैक्ट. आपको याद है वैसे बता क्या रही थी? ओके, बेस केस नहीं लिया. यस, गुड. ओके, मैं
IH की दो टर्म्स कैसे 2 हो सकती हैं साहब?
दिस इज व्हाट इज लाइक Pn है, तो n कोई Pn में ये नहीं गिवन ना कि n शुरू वाले के आखिरी वाले ना. यस. इंडक्टिव हाइपोथेसिस किस पे लगाऊं? किस पे?
अब घोड़ों का कलर क्या है? अगर पहले 10 वाइट है, जरूरी तो नहीं आता उसको पैटर्न कोई नहीं.
सारे एक जैसे तो पैटर्न नहीं है.
पैटर्न होता तो नहीं है ना. 10 पहले फॉर एग्जांपल
वो तो आपको वैसे भी जब आपने घोड़े देखे हुए इसलिए आप कह रहे हैं ना. अदरवाइज यहाँ पे हमारे प्रूफ में तो प्रॉब्लम, हमारे प्रूफ में
अगले वाले के लिए आ सकते हैं.
नहीं, यू राइट. सो यू फील कि समथिंग इज रॉन्ग विद इन द प्रूफ. तो व्हाट इज दैट थिंग? व्हिच स्टेटमेंट? Which statement? Yeah, but like we have proved that they are all of the same color, right? So then there's something. Okay, if you're not convinced with the original statement, because you saw some 2 horses जिनके different colors थे, तो the statement is false. That's fine. So something should be wrong within the proof. No, otherwise हमने proof में true भी कर दिया. So one thing is your intuition says this should be false, but mathematically it says it's true. Yes?
Inductive hypothesis जो है आपका wrong.
Inductive hypothesis says कि Pn is true. So what is the original? Any n horses. What is the original statement? Any n horses have the same color, which means those n horses could be starting n, could be last one, could be दरमियान वाले. So what is wrong with that? तो वो तो हमने सारी ऐसी की हैं क्योंकि हमने कहा था कि देयर इज़ लाइक वो वाला जो कहते हैं आपके पास पाइल ऑफ डोमिनोज, फर्स्ट वन फॉल्स, वो हमने शो कर दिया कि अकेला घोड़ा है तो उसका कलर सेम होता है, एंड देन वी आर डूइंग इट फॉर पी के एंड पी के प्लस 2. इसमें ऐसे ट्रू है, ये देखो ना कि व्हाट वी डिड वाज कि हमने कहा था कि n+1 हॉर्सेज हैं, दिस इज व्हाट वी हैव टू प्रूव दैट दे हैव द सेम कलर, बट आवर इंडक्टिव हाइपोथेसिस सेज दैट फर्स्ट n हैव द सेम कलर. Our inductive hypothesis that last n also have the same color. Our statement does not say कि उनका क्या order हो. So any order of n horses have the same color. Could be the first n, could be the last n, could be n anywhere in between. Okay. So if now just quick अगर आप पहले question के ऊपर कि so there is an overlap.
Sir, the inductive hypothesis is wrong. How are we assuming the n horses have the same color? The assumption is wrong. So everything.
Where did we assume? देखो वो तो फिर अगर ओके सो लेट्स सम वेरी इंटरेस्टिंग क्वेश्चंस आर कमिंग अप, सो लेट मी ट्राई टू एड्रेस वन बाय वन. आपने याद रखना है, अपना क्वेश्चन भूलना नहीं है. ओके सो वन क्वेश्चन इज कि हमारा इंडक्टिव हाइपोथेसिस हो सकता है गलत हो, डेफिनेटली. ओके लाइक इज इट द केस, हमने अभी तक जो पढ़ा है कि इज इट द पॉसिबिलिटी दैट पी के कैन बी ट्रू, पी के कैन बी फॉल्स? If that is false, हमारे जितने हमने प्रूव किया सारे गलत हैं फिर, because we assumed in all of them that pk is true. So let me very quickly jump back to the क्या हो गया इसको, to that first slide. Where was that? See, there are two things. We established the base case, so first tile false. The second thing was if the first falls, then it hits the next one. If it hits the next one, the next to next is hit. So इसी sequence में some ith will fall, that is given. We are not supposed to establish pk की truthfulness, that is given. Otherwise हमारे सारे वाले जो प्रूफ हैं, मैं बस let me try to quickly add. So इसमें सारे वाले मुश्किल वाले एग्जाम्पल्स आ गए, बट इसमें सब में ये होगा कि otherwise we'll be stuck. जो हमारे सिंपल फर्स्ट n नंबर्स का सम था वो भी फिर गलत प्रूव हो जाएगा ना. या बेस केस ठीक है. अच्छा यप
आपने जनरलाइज कर दिया टू एंटर
या तो यू कैन एन की बजाय आप क्या कर लें,
बेस केस तो बेशक एक
एन की बजाय आप क्या कर लें. ओके मुझे एक बात बताएं वैसे, यस समबडी हैड क्वेश्चन देयर. यप
What if there's a 401 first horse that is not the same color?
if there are 401 horses,
What if the 401st horse is not the same color?
so then our inductive hypothesis is not wrong, not correct. Our inductive hypothesis says what? Says that Pn is true, which means that any n horses have the same color.
So then it will be true, twice false, false. Because the 400
But true implies true as well, भी true होता है ना.
अब तो false हो गया.
कैसे?
401st horse is not the same color.
That's what you saw like practically, right? But our mathematical like justification is not proving that thing, na? That's the bottleneck. किसको? Any n.
सर इसको हम फर्स्ट 10 नहीं कर सकते, गलत ही है सर. फर्स्ट 10 हॉर्सेस आप चेंज करके फर्स्ट 10 हॉर्सेस नहीं रख सकते.
फर्स्ट n horses, उससे क्या फायदा होगा आपको?
वो लास्ट वाली जो ओवरलैप होता है वो.
ओके वेरी गुड. आप दोनों की बहुत अच्छी ऑब्जर्वेशन है.
सर यहाँ पर जो हमारी इनिशियल स्टेटमेंट है एन हॉर्सेस कैन हैव द सेम कलर, हमने इसको प्रूव करना था लेकिन हम उसको इंट्रो एज एन
नहीं वो पी के कर रहे हैं ना, पी के हॉर्सेस हैव द सेम कलर. दैट्स वो तो हमने सब, मैं कह रहा हूँ वो तो हमने सब पे हमें ऑब्जेक्शन होना चाहिए था ना, कि हमने अभी तक जितने किए हैं उन सब में हमने ये किया था. ओके यप आपको क्वेश्चन याद है अभी तक, भूल गए? अच्छा अच्छा ओके. Why will that help?
Because then one horse might not have the same color as the other horse.
Okay, three people have the similar kind of viewpoint now. 1, 2 and 3. So the viewpoint is that ओके इनके व्यू पॉइंट से पहले मतलब एक और क्विक चीज़ कि इफ़ यू रिकॉल एनी ऑफ द प्रीवियस प्रूफ्स, तो हमने कहा था बेस केस के लिए ट्रू है, क्या वो बेस केस +1 के लिए ट्रू होगा? बेस केस +1 के लिए वो ट्रू होगा? वाई? We can either directly plug in things on left hand side and right hand side and see it works, or we can use pk plus 1 wali substitution and we can see it works. But the problem is, okay, can you see it again, any of you? जो आपने कहा था कि क्या होना चाहिए? I forgot that thing. वो कह रहे हैं कि n, so if n is 2, if there are 2 horses, what will happen? Will this logic work? If n is 2, if n plus 1 is 2, तो फर्स्ट n हॉर्सेस का कलर क्या होगा? सेम. क्यों? हाँ, pk is true and there is another reason as well, क्योंकि एक ही हॉर्स रह गया है. या so n plus 1 is 2. If n plus 1 is 2, तो how many horses we have in total? 1. In total we have 2 now. So if there are 2 horses, तो फर्स्ट n horses जो होंगे और लास्ट n horses होंगे उनका तो कलर सेम होगा. Statement inductive hypothesis will be true. But if they don't have the overlap, are you getting my point? Draw 2 horses and see is there any overlap in n minus 1 and first n minus 1 and last n minus 1. There is overlap. कैसे? No, I'm saying draw only 2 horses. These are many more horses. So if n is fixed, so if n is 1, okay, let me try to write here. किस तरह के होते हैं horses? Let me try to draw them. There are some eyes as well. Okay, if n is 2, n minus 1 कितना होगा? Leave the last horse, n minus 1 is this part, this has the same color because we know, right, from the base case. And the last n minus 1 is this part, this also has the same color. Can we establish something on 2? If there is no overlap, okay, we have, the theorem is that every integer which is greater than or equal to 2 can be written as a product of primes. What is the prime number? Okay, very good. Is 1 prime? Okay, so like more concrete definition could be that number of factors are exactly 2. So 1 ka factor is 1, so that does not qualify the definition of prime numbers. Okay, so if we try to write this whole thing to Pn means that n can be factored into primes. So the first prime number is 2. So इसकी base case is conveniently true because 2 is, so any prime number के लिए this whole statement is true, right? You don't need to multiply anything with that. So that itself is the prime factor because n can be factored into primes. So 2 is factor of itself. So base case is very conveniently true. So assume that Pn is true. And अभी इस वाली story में you have to keep that horses वाली example in mind as well. So horses have something to do with primes as well. So assume that P22 is true, which means 22 can be written as product of 2 primes, which are 2 and 11. So our task is to prove Pn plus 1. So Pn plus 1 is 23. So P23 is something which we have to prove. So 22 does not have to do anything with the prime factorization of the next or previous number. Is everybody with me? As far as the problem side is concerned, we are trying to apply induction, but it does not seem working. Why? Because pk is true. Like this is not the formal proof, but as an example or intuition, we have plugged in a value over here of k. Let's p is 22. So p22 is true. We don't need to establish, but this is like inductive hypothesis. But even if you want to see 22, so 22 can be factored as 2 or 11 ka product. So our next task is P23 को prove करना. P23 is prime which means 23 is factor of itself. तो उसके जो factors हैं, they have nothing to do with the factors of 22. So we are not even using our inductive hypothesis to prove the next number. Part 1. And same way, if P23 has been established कि ये अपना आपका factor है, we don't need to do anything. So using P23, what we can do with P24? We can't do anything because 24 के जो prime factors हैं, they are altogether different. So how we can use 23 then? We can't. So problem है ना? Let's have a relook at the basic principle of mathematical induction. What was this principle? There are two things which have to be true. P naught is true and Pk implies Pk plus 1 has to be true for all k. If both of them are true, then we can say that the claim is true for all n. Okay, let's have a slightly deeper look at this expression. What does this say? Second part, P naught के बाद वाला. This says for all k is starting from the base case. Pk implies Pk plus 1. Let's try to write them down somewhere as a list. So if P naught is true, then what does that mean? P1 is true, Pk plus 1, that's what it means. If P1 is true, then P2 is true. If P2 is true, then P3 is true. If P3 is true, then P4 is true. And if some Pk is true, then Pk plus 1 is true. So this is something very obvious. Now what I'm going to do is that I'm trying to rewrite this whole thing. This actually means that, so P naught implies what? This implies that P1 is true. So जब हम inductive hypothesis कहते हैं, so that's why it's true, because if this thing is true, then P1 is true and we use that, we establish the next step. If you look over here, this is the same expression which we saw at the start of induction. This is being applied on all k, right? Which means when we say all k, we should be able to recall that quantification for all wali. That means that there is an and between all these things. So all of these implications have to be true, right? Which means that in order to establish Pk plus 1, all of the previous implications have to be true. Pk has to be true, Pk minus 1 has to be true, Pk minus 2 has to be true, and this keeps on rolling back. Is everyone with me on this? That all previous implications have to be true in order to establish Pk plus 1. And that's exactly we are going to apply now. And so that is not a new thing, that's not a new concept, that's just the way we are going to use it in our proofs, because in our previous simpler proofs, if you have seen so far, we're just using one previous Pn to establish Pn plus 1. Now in order to establish Pn plus 1, we can use any of the previous propositions. And they are very intuitive, they have to be true. They are already given to us, but we are not using them, right? So when we start using them, we call it strong induction. So induction का एक और version आ गया, which is strong induction, which means that for all I which are from 0 to k, if all previous of them are true, so if all of them are true, then Pk plus 1 is true, right? And that's the kind of reasoning which we are going to apply for that prime wali example जिसके ऊपर simple induction was not looking very obvious. So main change over here in the way we'll be using strong induction is that base case will remain same, inductive hypothesis will remain same, except this thing. Previously we used to say that it is true for some Pk. Now we'll say that it is true for Pk where k is anything from 1 to n, because we can use any of the previous results to establish the next one, right? Is everyone intuitively okay with this whole construction? Because this takes us back to that visualization जो हमने शुरू में बार-बार देख रहे हैं कि in order to have this last tile fall, all of the previous have to fall, right? That's already there, but we are using it because our claims or our our statements were simple enough, so we were only using ith one to establish I plus 1 wali. So now let's go to that prime wali stuff again. So P2 is true, that is obvious, because 2 is a prime number, so that's the base case. So that is factor of itself. So for all primes we don't need to do anything. So inductive hypothesis is that Pk is true for all k ranging from 1 to n. And using this inductive hypothesis we are going to establish something for Pn plus 1. So what could be the possibilities? So if n plus 1 is prime, जो हमने 23 वाले केस में देखा था, ये 2 वाले केस में देखा था, तो things becomes very obvious and Pn plus 1 is true conveniently. We don't need to do anything. If it is not prime, so then n plus 1 is a factor, is a product of two factors, a and b. Can a and b be greater than n plus 1? No. And like else is the case when n plus 1 is not prime. So none of them is 1. So it is guaranteed that there would be some a and b such that both of them are smaller than n plus 1. If both of them are smaller than n plus 1, then we are falling into this category where we say that all previous possible substitutions of k, inductive hypothesis was true. So a and b have to be less than small n, and inductive hypothesis is true for all of them, so we are done. Okay. Take a moment to absorb this, and if there is any question we can address this before we look at the last example. So let me try to say it again, right? So the only difference between the previous way of proving things using induction and this one is that over here we are using all previous results. In the previous version we are only using k minus 1 वाला result. या आप k minus 1 भी use कर सकते हैं, k minus 2 भी, anything smaller than k, which like something between 1 and that number itself. Okay, so this is just a comment that prime numbers are very important. They are building blocks of natural numbers. So this is the last ICP and then we'll stop. तो आपके ऊपर है, अब जितनी जल्दी आप stop करेंगे तो we'll stop that quickly. Let's try to understand this first and then solve it. What is power of 2? What does that mean? 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3 and so on. So all even numbers are powers of 2, right? Yes, no? All even numbers are power of 2. Is the statement correct? No. Why no? 1 bhi hai. Okay, 2 raised power 0 is 1. Okay, you're right. Other than 1, is it true? Okay, very good. So all even numbers are not power of 2. So they are like, if you look at the gaps, so there are many even numbers which are being skipped. 6 is not there, 10 is not there, 14 is not there, and so on. Oh, sorry. Huh? Yeah, but this is sum of all those powers, right? Distinct powers, which means that none of them is overlapping. But the point is your 2k, is it guaranteed that 2 की power भी है? Like 6 is 2k, but that's not a power of 2. Yeah, distinct means unique. मसला हो जाएगा. But claim is very big, right? It says that any number can be done with. ठीक है? But like we have to apply like this induction stuff, right? So what will be the base case? The smallest number is power of 2, which is 1. So 1 is which is what? Yeah, it's 1, right? It says every positive integer. So first positive integer is 1. So 2 raised power 0 is 1. So we are okay with the base. So base case is very obvious, right? 2 raised power 0 is 1 because it applies on every positive integer. So 1 is our baseline. So it says that if it is true for pk, it has to be true for pk plus 1. So what does pk mean? Say it again. Very good. K can be written as sum of distinct powers of 2. So inductive hypothesis says that Pn is true, Pk is true for all k between 1 and n. we are going to apply strong induction, right? So it's true for all previous values of k, including k minus 1, k minus 2, and so on. So if based on this thing, we have to imply that pk plus 1. So what will be pk plus 1? Okay, what does pk plus 1 mean? What does pk means? Pk means that k is an integer which can be written as sum of those powers of 2. Yeah, let's assume that's true. And if that is true, then this thing is true as well, that for all k which range from 1 to n, from the base case up till n, right? So pk plus 1 means what? We are adding 1 into. So pk plus 1, हमारे पास k के लिए we have established this thing from inductive hypothesis, we add 1. So what this new number के लिए we have to do that thing now. Okay, so sorry.
If we establish that PK that the sum of the powers,
Can you please say it again? Sorry.
since we've established that for k can be written as a sum of powers of 2,
Mm-hmm.
then if we're adding 1 to get the next term, we're just adding 2 to the power of 2.
So okay, so k plus 1 is what? Is the what did it say? So one possibility could be that if the previous one can be written as powers of 2, तो उसमें 2 raised power हो सकता है 1 पहले ही हो. If 1 is already there, 2 raised power 0 is already there, what does that mean? K was odd. Then k plus 1 is E1. Then k plus 1 is k plus this whole new thing. This is same as k plus 1 over 2 plus k plus 1 over 2. Because if it's even, it can be written as sum of 2 equal integers, right? And if this is odd, then what? Then this can be written as k, because then it does not contain 2 raised power 0. Then it does not contain 2 raised power 0. If it is odd, what is odd? If k is odd, then k plus 1 is even. I think I said it the other way around, right? So k plus 2 naught is what? K क्या था? K was sum of some powers of 2. If k was even, then it did not contain 2 raised power 0 as one of its, because 2 raised power 0 is 1. 1 was not being added up. So we can use 2 raised power 0 over here. Otherwise, ये क्या होगा? Can we write it like this? So if k plus 1 is even, then it can be divided into 2 equal halves. नहीं? So k plus 1 is k plus 1 over 2 में I'm interested क्यों है? Because this is something here, it can be written. K plus 1 2 over here again is within this range 1 और n वाली. So using the strong induction, both of those parts जिनको हमने जिसमें sum को partition किया है, both of them can be written as powers of 2, no? Okay, so that's it from my side. Thank you very much.